Welcome! This time we will show how the equations for the forces acting on the vehicle are combined into a vehicle model, which can be used for simulation. A vehicle model is a mathematical model which can determine how the vehicle as a whole responds to different inputs. In our case, the vehicle model only models the longitudinal behavior. Note that the vehicle model does not include a model of the powertrain. The powertrain model will instead use the output of the vehicle model as its input, and it will be presented later. The output of the vehicle model is the traction force required from the powertrain in a specific driving situation. The inputs are vehicle speed, vehicle acceleration, and road inclination angle as they describe the driving situation. The road inclination angle can of course just as well be expressed as the road gradient if that is preferred. There are also other things which influence the output of the model, like vehicle mass, front area of the vehicle, and the friction and drag coefficient. These are called vehicle model parameters. They can be set once and are constant when analyzing that particular vehicle, no matter which driving situation is analyzed, while the input variables can vary constantly when the vehicle is driving. The main equation of the vehicle model is of course the earlier presented equation for the required traction force, which equals the sum of aerodynamic resistance, rolling resistance, gradient force, and required net force. Each of the four forces can be determined with the function. These functions show that we need the three input variables to be able to calculate the value of each of the four forces. Now we will look at how the vehicle model looks in the QSS model in Simulink. The vehicle model block in QSS looks like this. The three inputs are all recognized from our earlier discussion, but the model has three outputs instead of just one. However, it can be seen that two of them are only the vehicle speed and vehicle acceleration, which are the same as two of the inputs. These are only sent as outputs since it makes it easier to build a complete simulation model that way. We can set the model parameters in a dialog window, which we open by double-clicking on the model. In this window, we can see what default values the model parameters have. If we need other values, we just enter them and press the Apply or OK button. Pressing the OK also closes the window. We can also open the QSS vehicle model to see what's inside. If we look at the model, we find that the model calculates the traction force as the sum of four other forces, as in our equations. Each of the four forces are calculated in a subsystem corresponding to the four functions we defined. These four subsystems also use the three vehicle model inputs as their inputs. Notice also that the vehicle speed and acceleration are not modified within the vehicle model, but are only passed on to the output. So, we can conclude this video by noting that the QSS vehicle model is simply a Simulink implementation of the force functions we have discussed.